Welcome back to our Exploring PCB Manufacturing from Scratch series. PCB stands for Printed Circuit Board, and printed simply means the circuits are formed through a printing process. PCB manufacturing involves several key stages: inner layer fabrication, lamination, drilling, PTH, outer layer fabrication, solder mask, silkscreen, surface finish, testing and inspection, outline, and packaging and shipping. Remember in our first episode when we talked about substrate selection? That's right, it's the copper-clad laminate, CCL. Today, we're diving into outer layer fabrication, which is performed directly on this it. Note, not all PCBs require separate inner and outer layer process. Only multi-layer boards, for plus layers, require inner layer process. For single/double layer boards, the process skips directly to drilling. Few people realize that outer layer process actually involves two main methods: positive film process and negative film process. The key difference lies in the negative film process produces traces with a trapezoidal, while the positive film process is inverted trapezoidal. The positive film process is less affected by copper thickness, whereas the negative film process is more sensitive to it. Typically, min line width is 50 to 75 micrometers. However, since the negative film process produces traces with a wider base, they offer much better adhesion compared to the positive film process. Both have pros and cons. The positive film process is generally more expensive. Now, most PCB factories utilize the negative film process. But today, we'll dive into the more complex and expensive positive film process. By the way, Next PCB recommends the optimal process based on your trace width requirements and application, balancing performance and cost. Reach out if you need prototyping services. The positive film process involves these steps: material cutting and edge grinding, dry film, exposure, development, tin plating, film stripping, etching, tin stripping, AY, and impedance testing. First, the copper-clad laminate is cut to size by a shearing machine and fed onto the conveyor belt. As it moves along, the edges of the cut panels get trimmed. Next, dry film. We cover the board with a blue photosensitive dry film. This special blue film has a trick. When exposed to light, it dissolves easily in developer solution, leaving the circuit pattern exposed. Then comes exposure and development. The PCB board goes into an exposure machine with a circuit film mask. UV light shines through the mask onto the blue film, marking where we'll etch away the exposed areas later. To protect the exposed copper circuits, we electroplate them with tin. This tin layer acts like armor. It shields the copper from both stripper and etcher chemicals. The areas still covered by film won't get plated, so they stay unprotected. After electroplating, the copper-clad board first passes through a stripping machine to remove any remaining blue dry film. It then enters an etching machine, which etches all copper not protected by tin. Finally, we strip away the tin coating, leaving behind only the clean copper circuit pattern we need. The final step is inspection. The circuit board will go through an AOI scanner. It uses optical imaging to scan the traces, then compares the results with the customer's original design files to check for any breaks or defects. After passing inspection, traces with controlled impedance requirements undergo testing to ensure signal integrity and continuity. That's all for outer layer processing. Stay tuned for more PCB knowledge. See you again.